Imagine a night, no flashlight, no blanket, no stove, no walls, just you, standing in the dark, in the middle of a forest, and somewhere close by, you can hear something breathing that is not human. Now take away one more thing. Take away fire. No torch to scare off predators. No warmth to survive the cold. No way to cook your food, sterilize your water, or even see 3 feet in front of you. This wasn't a horror movie. This was Tuesday. For nearly 2 million years, this was simply what it meant to be human, or rather, what it meant to be one of our ancestors, walking around this planet long before anyone figured out how to strike a spark and keep it alive. Here's the question that should honestly keep you up at night. If you took away fire, the single tool most of us consider the foundation of human civilization, how did our ancestors not just survive, but slowly, stubbornly, evolve into us? Today we're going back, way back, before the campfire, before the hearth, before the idea of cooking even existed, and we're going to walk through exactly how early humans made it, through some of the harshest conditions on Earth using nothing but biology, behavior, and sheer bloody-minded persistence. Stay till the end, because the answer to this question says something uncomfortable about what humans are actually built for. And it's not comfort. The timeline nobody talks about. Let's set the record straight first, because most people have the timeline completely wrong in their heads. We tend to picture cavemen sitting around a fire from the very beginning, but the genus Homo, our direct evolutionary line, goes back roughly 2.5 million years. Controlled, reliable, everyday use of fire. That's a much more recent story. Most researchers place habitual fire use somewhere around 400,000 to 1 million years ago, and even that's debated. Some evidence pushes it earlier. Some argues it took much longer to become a daily habit rather than an occasional, opportunistic event. Do the math on that. That means for roughly 1.5 to 2 million years, the majority of human evolutionary history, our ancestors were surviving completely without dependable fire. Not before civilization, before campfires, before cooking, before warmth on demand. And here's the part that should really humble us. During that fireless stretch, our ancestors weren't just surviving, they were spreading. Homo erectus, one of our early ancestors, walked out of Africa and into parts of Asia and colder regions of Europe without guaranteed fire. They were making stone tools. They were hunting large animals. They were raising children to adulthood in an environment that would kill most modern humans within days. So the real question isn't how did they survive without fire. The real question is, what did evolution have to build into the human body and human behavior to make that possible? Because trust me, it built a lot. Eating raw, the diet nobody would choose today. Let's start with the most obvious problem, food. Today, if you eat raw meat, most doctors will look at you like you've lost your mind. Raw meat carries parasites, bacteria, all kinds of risk. Cooking kills pathogens, breaks down tough fibers, and unlocks calories that would otherwise pass straight through the body unused. So without fire, how does a hunting, meat-eating ancestor not just get sick and die? Turns out, the human body, and more specifically, the hominin body, came with some built-in defenses long before cooking existed. First, stomach acid. Human stomach acid is significantly more concentrated than in most other primates. That level of acidity is brutal on bacteria and parasites. It's one of the reasons some researchers believe our ancestors could tolerate a much raw, more scavenged diet than we assume today. Second, fat and organ meat were prioritized over muscle meat. This is a detail people miss constantly. Popular imagination pictures early humans gnawing on a raw steak. In reality, the evidence from butchery marks on ancient bones suggests something different. Early hominins were often going straight for bone, marrow, brain tissue, and internal organs. These are calorie-dense, nutrient-rich, and in the case of marrow, protected inside bone where bacteria has a much harder time reaching it. Marrow was basically nature's sealed energy bar. Third, persistence and timing. Meat was often eaten fresh, immediately after a kill or a successful scavenge, not left out for hours. Fresh kills carry a fraction of the bacterial load of meat that's been sitting exposed. Early humans weren't storing raw meat in the sun for 3 days. They were eating it close to the moment of the kill, sharing it fast among the group before spoilage became a real risk. And fourth, plants did most of the heavy lifting. This surprises people, but the majority of calories for most early hominins likely came not from meat, but from roots, tubers, nuts, and fibrous plants. Digging sticks, some of the oldest tools we found, were probably used to pull starchy roots and tubers out of the ground. These could be eaten raw, and while less calorie-dense than cooked starch, they were reliable, abundant, and far lower risk than a fresh kill. So the diet wasn't reckless. It was calculated, even if that calculation was happening through instinct and trial and error passed down over hundreds of thousands of years, not through anyone writing it in a notebook. The body built for the job. Here's where it gets genuinely fascinating. Because the human body itself changed to make a fireless lifestyle survivable. Take sweating. Humans have an extraordinary number of sweat glands compared to almost any other mammal on the planet, several million of them, spread across nearly the entire body. Combine that with comparatively less body hair than our primate cousins, and you get a cooling system that is, frankly, one of the best in the animal kingdom. Why does that matter for surviving without fire? Because it's not just about staying warm. It's about a hunting strategy called persistence hunting. Without spears that could reliably kill from a distance, without guns, without traps in the early stages, one of the strategies available to early humans was to simply outlast an animal. Run it down. Not by being faster in a sprint. Almost every prey animal beats a human in a short sprint, but by chasing it over hours, in the heat of the day, until the animal overheats and collapses from heat exhaustion, while the human, cooled by that incredible sweat system, keeps going. That's not a myth. Some hunter-gatherer groups, like certain San communities in the Kalahari, have been documented using persistence hunting well into modern times. It's slow, it's exhausting. It can take 3, 4, 5 hours in extreme heat, but it works, and it requires zero fire, zero advanced weapons, just endurance, tracking skill, and a body engineered for heat dissipation. Then there's the digestive system itself. Human guts are shorter, relative to body size, than you'd expect for a primate our size. Some researchers argue this trade-off, a smaller gut, paired with a larger brain, was made possible partly by a shift toward more energy-dense foods like marrow, fat, and eventually cooked food. But even before cooking became reliable, a diet rich in fat and marrow may have supported this shift. The point is this: evolution wasn't waiting around for fire to solve every problem. The body itself was quietly being redesigned, sweat glands, gut length, stomach acidity, all optimized for a world where you couldn't always guarantee a flame. Staying warm without a flame. Now let's talk about the cold, because this is where things get genuinely brutal. Fire feels essential for warmth because, in most modern contexts, it is. So how did Homo erectus survive in regions of Europe and Asia, including places with real winters, without dependable fire? Part of the answer is simple. They mostly didn't go to the coldest places. Early hominin expansion out of Africa tended to follow warmer corridors, coastal areas, river valleys, regions with milder climates. The truly frozen environments deep into Ice Age Europe, Siberia, those were settled much later, largely after fire use became reliable, and after more sophisticated clothing and shelter technology developed. But even in moderately cool climates, survival without fire required real adaptation. Natural shelter became critical: caves, rock overhangs, dense tree cover, anything that blocked wind chill, which is often more dangerous than the raw temperature itself. Wine strips heat from the body far faster than still cold air. Body fat distribution and activity patterns also mattered. Staying active generates body heat. Early humans weren't sitting still for long stretches. In the cold, inactivity in a cold climate without fire is a fast way to die of hypothermia. Groups likely huddled together at night, sharing body heat, which is a survival strategy, still used by mountaineers and soldiers caught without proper equipment today. It sounds primitive, but body-to-body heat transfer is remarkably effective in an emergency. There's also growing evidence that early hominins used rudimentary animal hides for warmth well before they had needles for tailored clothing. Simply draping a hide over the shoulders, even without stitching, provides meaningful insulation. Stone tools show scraping patterns consistent with hide processing far earlier than we once assumed, meaning basic hide use for warmth likely predates fully reliable fire control. Put it all together: smart geography, shared body heat, natural shelter, and early hide use, and you start to see how a fireless population could survive in climates that would otherwise be lethal. Not comfortably, not without real losses, especially among the very young and very old, but survivably, generation after generation. Safety in the dark, surviving predators without fire. This is the part people underestimate the most. We tend to think of survival purely in terms of food and temperature, but for most of human evolutionary history, being eaten was a genuine, everyday risk. Fire, when humans eventually mastered it, became an enormous predator deterrent, Most animals instinctively fear flame. Without it, how did early humans avoid becoming dinner for the large predators that shared their landscape? Big cats, hyenas, and other now extinct megafauna. Predators that were considerably larger and more dangerous than anything most of us will ever encounter. The answer, overwhelmingly, is numbers and vigilance. Early hominins were intensely social. Group living wasn't optional, it was the core survival strategy. A lone individual in the open savanna was extremely vulnerable. A group of 20, 30, sometimes more, with some members always semi-alert, was a completely different proposition for a predator to consider. Most predators are opportunists. They target the isolated, the injured, the very young, or the very old, not a cohesive, alert group. Sleeping arrangements likely reflected this directly. Elevated or enclosed sleeping sites, caves with narrow entrances, rock shelters, possibly even trees in earlier periods, reduced the angles from which a predator could approach unnoticed. A narrow cave mouth means only one attacker can come through at a time, and it means the group can hear anything approaching well before it arrives. There's also a behavioral piece that's easy to overlook. Early humans were diurnal by preference, meaning active mainly during the day, precisely because so many dangerous predators are more active at night. By minimizing movement after dark and prioritizing safe, defensible resting locations before nightfall, early humans were essentially managing risk through scheduling, a strategy that required zero technology, just discipline and shared group knowledge passed down over generations. And frankly, this is where psychology enters the picture in a very real, biological way. The instinct to seek group safety, to feel unease in isolation, to want walls or barriers at your back while sleeping, these aren't just modern anxieties. They're inherited survival instincts from a period when being alone in the dark was genuinely, statistically dangerous. That unease you feel walking alone at night even today, that's not irrational. That's a couple million years of evolutionary memory still running in the background. Tools before fire, the first technology. Let's not forget the piece that made almost everything else possible, stone tools. Long before fire, hominins were already toolmakers. The Oldowan tool industry, dated back roughly 2.5 million years, represents some of the earliest deliberately shaped stone tools we found. Simple, sharp-edged flakes struck off a larger stone core. These tools mattered enormously for a fireless existence. Without cooking to soften food and break down tough fibers, mechanical processing had to do that job instead. Sharp stone flakes could cut through hide, scrape meat from bone, crack open marrow-rich bones that predators with weaker jaws couldn't access, and pound fibrous plant material into something more digestible. Think about that last point for a second, pounding food. Some researchers argue that simply pounding raw meat with a stone tool, essentially a primitive form of tenderizing, would have made it significantly easier to chew and digest, mimicking some of the softening effects we now associate with cooking. It wouldn't kill pathogens the way heat does, but it would reduce the mechanical effort and energy cost of digestion, which, over a population and over generations, matters enormously. Later tool industries, like the Acheulean hand axe, show increasing sophistication, asymmetrical, carefully shaped tools that took real skill and, importantly, real teaching to produce. That's a detail worth sitting with. Toolmaking required social transmission. Someone had to show someone else how to strike the stone at the right angle. That means early hominin groups already had structured learning, patience, and communication, the psychological foundations of culture, long before they had fire. So while fire eventually became the tool that changed everything, it wasn't the first tool. It was, in many ways, one of the later chapters in a very long story of humans using intelligence and cooperation to overcome physical limitations. What this actually tells us about human nature. Here's where I want to pull back and ask the bigger question, because a video like this shouldn't just be trivia. It should tell you something about who you actually are underneath all the comfort of modern life. For roughly 1.5 million years, humans survived brutal cold, active predators, food scarcity, and constant physical risk, without the single tool most of us consider non-negotiable for survival. And they didn't just survive, they expanded across continents. They raised children, they developed tools, cooperation, and eventually, language sophisticated enough to pass down survival knowledge across generations. What does that tell you? It tells you that the human default setting is not comfort, it's adaptation. Every single one of us alive today is descended, without exception, from ancestors who made it through conditions we would consider unsurvivable. With our current mindset, not the strongest individuals, not the luckiest individuals, at least not alone, the ones who cooperated, the ones who paid attention, the ones who taught their children what they knew. Even when there was no guarantee it would be enough, we live now in a world of instant warmth, instant food, instant light at the flip of a switch, and somewhere along the way, a lot of us have started to believe that this ease is the natural human condition, that struggle and hardship are aberrations, mistakes, things that shouldn't be happening to us. But the honest evolutionary story says the opposite. Hardship isn't the exception in human history, it's almost the entire story. Comfort is the recent, fragile exception. That's not a depressing thought if you sit with it properly. It's actually the opposite. It means the discomfort you're facing right now, whatever it is, a difficult season at work, a personal struggle, a moment where everything feels uncertain, it's not evidence that something has gone wrong with your life. It's the same test your ancestors passed, over and over, for 2 million years, without fire, without shelter guaranteed, without any certainty at all. And they made it through, generation after generation. Or you wouldn't be sitting here right now watching this. The transition, and what came next. Eventually, of course, fire did become reliable. The transition from opportunistic use, taking advantage of natural wildfires, carrying embers when possible, to genuine, deliberate fire-making was gradual, and it changed everything downstream. Cooked food meant more available calories, which some researchers connect directly to the dramatic growth of the human brain. Fire meant real protection at night, meant groups could gather in open spaces rather than only defensible ones, meant warmth in climates that had previously been off-limits. But it's worth remembering, fire didn't create human intelligence, human cooperation, or human resilience. It amplified traits that already existed. The social bonds, the tool use, the shared knowledge, the discipline around risk and safety, all of that was already there, built over a much longer stretch of fireless survival. Fire was a multiplier, not the foundation. So the next time you're facing something hard, something that feels like it's stripping away your comfort, your certainty, your sense of control, remember this. Somewhere in your ancestry, there was a human being, standing in the dark, with no flame, no walls, no guarantee of tomorrow, who chose to keep going anyway, who taught the next generation what they knew, who trusted the group next to them enough to sleep at night. That instinct is still in you. It didn't disappear because your life got easier. It's just been waiting for a moment to be needed again. If this made you think differently about what humans are actually capable of, let me know in the comments. I read every single one. And if you want to go deeper into how our ancient survival instincts still quietly shape the way we think, feel, and react today, that's exactly where we're headed next. I'll see you in the next one.